Okay, good morning students. Now, since I have completed with algebraic differentiation, so now we will go with the trigonometric differentiation. So under trigonometric differentiation, so let me revise. You have already learned in class 11 that the differentiation of sine x is cos x. Differentiation of cos x, we have negative sine x. Just to revise only. Differentiation of tan x, we have sec square x. And differentiation of sec x is sec x tan x. These four, we have a same pattern. What you need to observe here is, whenever you differentiate this co-function, you will always have one negative. Like differentiation of cos x, we have negative sin x. Differentiation of cot x, we have negative cos square x. Similarly, differentiation of cosec x, we have negative cosec x, cot x. So now we will directly jump for solving the questions. Now, I have already given the trigonometric differentiation. So now what we have to do here is, we need to know the identities. For this identities, I am not going to write on the board. Rather, I will give that identities soft copy, which I will paste in Facebook on my page. Please go through on my page. I will upload my formulas there, formulas for trigonometric identities. Then please download. Okay. So now let's go with this one. Y equal to sine 2x. Now we already know differentiation of sine x is nothing but cos x. And please remember, this trigonometric differentiation is only for science. This is not for business mathematics. Okay. So differentiation of sine x is cos x. Now this case, the logic remains same. The logic is, you need to always try to find out how many functions are there. In this case, we have two functions. That is, one it is sine and second one it is an angle. So if you have two functions, you need to differentiate two times, isn't it? So differentiate this one here. That implies dy by dx is equivalent to, whenever you go for first function, assume this whole thing second function as a x. Logic remains same that I taught on the algebraic. So what's the differentiation of sine x? It is cos x. But in place of x, what do we have? 2x. Is it okay? Then this sign is done. Go for angle now. This 2 is a constant. What's the difference of x? It is 1. So answer it is 2 cos 2x. Okay? So we'll go with Roman number 2. So Roman number 2, we have y equal to sine square x. Now see, sine square x means it is same as sine x times sine x, which also can be written as sine x whole square. Meaning the same, isn't it? So sine square x means sine x times sine x becomes sine square x, or you can write this one sine x whole square, which means this 2 is a power. So therefore here we need to find out how many functions are there. So in this case, we have two functions. One it is power and one it is sine. Angle no need, because differential x is 1. But if you have this angle other than x, like 2x, x square, whatever, other than x, then you need to take that one as a function and differentiate. Even though this x is a function, but we already know differentiation of x is 1. So therefore, first go with the outer function, because this power becomes the outer function. Okay? So dy by dx is equivalent to, first go with power, to keep this inside function as same, 2 sine x. Now power is done. Now differentiate sine. What's the difference with sine x? Difference sine x is cos x. So what is 2 sine x cos x? We have this identity where it says that sine 2x is nothing but 2 sine x cos x. I hope you remember this one. So 2 sine x cos x, we can directly write this one as a sine 2x. This is the final answer. Now let's see this question now. Tell me how many functions are here. This case we have 3 functions. First one it is power, second one it is sine, and third one it is an angle. So you need to differentiate 3 times. So let me go with outer function, which is a power. So we have now dy by dx is equal to, when you go for power, assume second and third function as x. So what's the differentiation of x squared? 2x, isn't it? So that means 2 sine x squared. This power is done. Now this becomes the outer function. This is a parent control here, and this is Yeah, this is an angle which is controlled by sine. So therefore this becomes the outer function. What's the difference with sine x? Difference sine x is cos x. In place of x, what do you have? Cos x square. Sine also is done. Logic is very simple. If you know that, if you get this logic, then it will be much easier. No need to put every time d by dx. What happens here, that means the step involved will increase. Here it becomes a large, okay? So directly go with now angle x square. What's the x square? 2x. Which is equal to, let me write this 2x first. This case, now we have an identity where sine 2x is 2 sine x cos x. This looks almost similar, isn't it? But only the difference is here the angle is squared. So if the angle, if you square this side, make sure you also square this side. If you multiply this angle by 2 here, in both the cases, you have to multiply here also by 2. If you divide this angle by 2, you have to divide here also by 2. That is a manipulation of the identities. You must have learned in class 11. There's a trigonometric function, trigonometric equation 1 chapter, okay? So here the angle is squared. So if you square this side, make sure you square this side as well. Which means 2 sine x square cos x square becomes now sine 2x square. Make sure you go with the final answer. Try to use the identities. Make sure you make thorough with the identities, okay? So let's go with the Roman number 4. Now, tell me how many functions are here in this case. I'll give you a second. How many functions here? How many functions? Say, this case, we have, this is the outermost function. Say, take this one as a number 1. But when it comes to this one, this angle, that means this part becomes the second function. Sine becomes the third function, and the angle last one becomes the fourth function. How many functions here? 4 functions. You need to differentiate 4 times. So now more space. So when you differentiate now, that implies dy by dx. When you go for number 1, as in second, third, fourth, this whole thing has an x. So what's the differentiation of cos x? Differentiation of cos x is negative sine x. So this becomes negative sine, but in place of x, substitute this. We have sine cube x square, which means this cos is done. Then go with the power. When you go for power, as in this third and fourth as a x, this becomes x cube. What's the differentiation of x cube? 3x square, isn't it? This becomes 3x square. That means 3 sine square x square. Wait, as in this one, a third and fourth is a x. What's the difference x cube? 3x square, isn't it? 3 will come in front. Then 3 minus 1 becomes 2. Then sine x square. Then next one. Now this part also is done. Go with the third one. What's a sine x square? What's the difference of sine x square? It is cos x square. Sine also is done. At last, remain with angle, which is equivalent to 2x. I hope you got it. Now, what we can do here is, let me try to manipulate. Here, see, very interesting here. 3 times 2, actually it's a 6. Oh, no need, please don't go with this one. Keep this 2 as it is. Write this 3x. 3x times, write this one here. Sine cube x square. Then one of them, split this one. We have here sine x square. Then 2 times, write this 2. Then 2 sine x square cos x square. Is that okay? Sine x square becomes sine square x square. Which is now, we have negative 3x. Let me write this one. Sine x square. Now, this case, 2 sine x square cos x square. What's that? I did in previous question. We know sine 2x is nothing but 2 sine x cos x. Please make thorough with the trigonometric differentiation, because till the calculus is over, we have to always deal with the trigonometric functions, okay? So, and then this identities, make sure you make thorough with the identities. Here it's a square. If you square this side, you have to square this side as well. That's a manipulation of identities. Now, in this case, substitute here sine 2x square. Then write the final answer. X I have already written here. Sine cube x square. So this will be the final answer. So now let's go with the Roman number 6. This case, sine is controlling all this function. So this is acting as an angle. So what I can do here is differentiate this as usual. Dy by dx is equal to differentiation of sine x is, what's that? Difference sine x? Cos x. As if this whole thing as a x. The difference in sine x becomes cos x. In place of x we have root of sine x plus cos x. This sign is done. Differentiate this now. What's the divided by root x? Assume this whole thing as a x again. Divided by root x is 1 by, I need more space. 1 by 2 root of sine x plus cos x. Alright, we are done with the root. Go inside now. What's the difference sine x? Cos x. What's the difference cos x? Negative sine x. We can do in one go, okay? If you know this logic, then we can do it directly. No need to put every time dy dx. So in homework also, try to use a special case and never put dy dx. I'm telling you. If you put dy dx, I will not accept the homework, okay? So now, it doesn't mean that it's wrong. Actually, it's correct only. But what happens is, when you deal with the large function, it gets complicated. I'm telling you. Right now, it's a very simple function. When you go with the integration, when you go down, and the differential equation, it really gets complicated. So therefore, never put dy dx. I'm telling you. So we have now, cos, let me write this one first. Cos of root of sin x plus cos x, and here it is cos x minus sin x whole divided by, we have here 2 times root of sin x plus cos x. Try to manage the space. Don't write this 2 times root of here. It doesn't look good. Try to write in middle, okay? At the center. Thank you. Okay, let's go with the Roman number 7 now. When it comes to Roman number 7, we have 2 functions. One is algebraic, one is trigonometric. So we can use a product rule. So take this one as a u, take this one as a v. When you differentiate now, product rule, please apply product rule now. Dy by dx is equal to, keep u as it is, differentiate v. But in order to differentiate v, we have 2 functions, sine and 1 by x squared, isn't it? What's the difference sine x? Cos x. Is that correct? Sine is done. Again angle, do not forget angle. So what's our special case? What's the differentiation of 1 by x squared? I told you, what's the difference of 1 by x squared? It is negative 2 divided by x cube. I hope you remember now. Algebraic and algebraic. If you are not thorough with algebraic, you will face problem in trigonometric. If you are not thorough with trigonometric, you will face problem under logarithmic exponential, and problems goes on increasing, okay? Make sure you make thorough, because once you complete with algebraic under trigonometric, it will be a mixture of algebraic as well as the trigonometric. But once you complete algebra in trigonometry, then we will go with logarithmic, and the functions get larger and larger. Logarithmic will be a mixture of algebraic and trigonometric. So that means, again, if you go with exponential, the exponential will, it consists of algebraic, trigonometric and logarithm. All the functions will get mixed. Then function gets larger. If you face problem with algebraic, then definitely the problem, you will face problem in differentiation. So now, plus, now you keep this one as it is, sine of 1 by x square. Differentiate x cube, what's that? 3x square. Okay. I can cancel this x cube, there's no problem. Then, let me write this positive value in front. 3x square times sine of 1 by x square. Is that okay? Then minus 2 cos of 1 by x square. Can I use any identities? No, this will be the final answer. Okay?